Hello guys, welcome to my channel. Let us continue sets exercise 2.2 by AN. Let us start. Today's motivational quotes is परों को खोल ज़माना उड़ान देखता है, ज़मीं पर बैठकर क्या आसमान देखता है. Being a Indian, we like the quotes in Hindi. So I express my quotes in Hindi. Let us continue in the English the topic. Okay. With this new motivational thought, new motivational topic, let us continue our exercise. Okay, let us continue types of sets. Before explaining, I'll tell you in the form of diagram. Okay, let us take this is a set which is called mu, universal set. Okay, here mu is the universal set which has the elements 1 2 3 4 5. Okay, and in this a small subset is there, A, which has the elements, A has the elements 3 4, means 3 4 is present in A, and 1 2 5 this is present in universal set. Okay, 3 has the elements 3 and 4 only, so this can be written as A is subset of mu. A is subset of mu. This symbol is represented as subset. Okay, I'll tell you another example of this. Okay, take the example of what are whole numbers. Whole numbers are starts from 0 1 2 3 and so on. And what are natural numbers? Natural numbers can be starts from 1 2 3 and so on. So all the elements of natural numbers is present in W. So this can be written as, telling you with the diagram, W where represents the whole number and N represents the natural numbers, means all the natural numbers are present in W. So we can write this as N is subset of W. N is a subset of W. This is called subset, means all the numbers are of natural numbers are present in W. Okay, this is the concept of subset. Okay, now I'll explain it. Instead of natural numbers, if you remove the natural numbers from the whole numbers, what is the element has been remaining? 0. Means if you remove all the natural numbers from the whole numbers, what is the element remaining? 0. Means this one element is remaining no. So it is called singleton set. Singleton set. This number is called singleton set, means only one element is there in the set. Okay, and if there is no element remains in the set, no element is remains in the set, this is called empty set. This is called empty set or void set. Okay, and it also be represented as 5. It also be represented as 5 if means no element is present in the set, is called empty set or void set. Okay, now let us take two sets in a set, in a universal set. This is universal set. Consider in universal set what are the numbers are present: 1 2 3 4 5 6 7 8 9 10. Okay, 10 numbers are there in a universal set. Consider set A. Set A 1 2 3 4 5 6. Okay, set A has 5 6 7 8 9 10 elements. A set has. B has 7 9 10. B has 7 9 10. Here A is represented as A is a subset of universal set. Again in that set, I'll represent this. Take like this 7 9 10. So again here in the A set you have another set B. In the A set you have another set B. B has the elements 7, 9, 10. Okay, so B is subset of A and A is subset of universal set. So in A set you have universal set, in that A is the subset of universal set, in that B is the subset of set A. Okay, if you will be confused, I'll represent this in another method. Okay, if this is a set U, this consider this as Asia. Okay, and consider set A as A, set A as India. In Asia you have one of the countries India, in that one of the state, this is B. In that you have one of the state Assam. Okay, you have one of the state Assam, means B is present in India, Assam is present in India, India is present in Asia. Okay, like that way B is a subset of A is subset in the universal set. So what are the elements in B which are subset of A, and A is subset of whole universal set. Okay, so we represent this as, you have understand this, Asia, in Asia we have the country India, in India it has been the state Assam. Okay, so mu is called as universal set, okay. A is represents as subset of universal set, okay. And B is subset of A. B is can be represented as subsets of A. Okay, now let us continue through two sets. This is universal set. Consider two subsets A and B. A and B. These are two subsets. Okay, 1, 2, 3, 4. Okay, and 1, 4, 5, 6, 7, 8. Okay, you can write this. Now take this as union. Now I'll explain you the concept of union of sets. Union of sets means here this can be represented as, it can be represented as U. Okay, this can be represented as like this. Okay, now write A union B. A union B means both the elements, considering this also, both elements present in the universal set, means 1, 4, 5, 6, 7, 8. Okay, A union B means A union B, both the elements of A and B, such as addition, we are adding all the values. Here we are adding all the elements. A union B, we are taking all the elements of A and B. Okay, and in universal set what you have, 1, 2, okay, represents with comma, 1, 2, 3, 4, 5, 6, 7, 8. In universal set you have all these, but in A union B you are taking all the elements of A and all the elements of B, and these elements of A and B are subset of A union B, is subset of universal set. A union B, this is the subset of our universal set. All the elements of A and B are present in this. 1 is present, as 4 is present, as 5 is present, as 6 is present, as 7 is present, 8 is present. Okay, all the elements of A union B is subset of universal set. Now consider the concept intersection of sets. Means it is represents as ulta u, means upside down u. Okay, and in this, what are the common elements? Here common elements between A and B, here it is called these 3 and 4. Here what are the common elements? 3 and 4 are common elements in both A and B. So these 3 and 4 are called A intersection B. A intersection B. This represents what are the common elements are present in A and B. Okay, what are the common elements present in A and B? Now consider if there is no common elements. If there is no common elements in between A and B, if there is no common elements in between A and B, it is called disjoint set, and it has the elements 5, means no elements are there. So it is called disjoint set or empty set or void set, but it has no elements in common, so it is called null set also. Null set means no elements are present in common, so it is called null set, or it is called disjoint set, no elements are present in common. Now here take difference of set. Difference of set means you are taking only if A is A minus B. Difference of set can be written as set A minus set B. In set A minus set B, you have to take only the elements present in set A only. You can't take the elements present in set B and intersection of set, common elements of set A and B. You can't take this. You can take only the elements present in set A only. If you want to represent such as mu A B, and if you want to represent B minus A, set B minus set A, means you have to take only the elements present in set B only, not in A. So you have to take only the elements present in set B only, not in A. Okay, now I'll give you an example. Set A has 1 2 3 4, and set B has the elements 2 4 1. Okay, take this 5 also, take this 5 also, take this. If you want to take say A minus B, then what are the elements you have to take? 1 and 2 is present, so you should not take 3. Sorry, 1 is also present, so 1 is also not, don't take 3 and 5. Okay, what are the elements present? 2 4 1 here present in base B, so should not take 3 1 2 4 1, but you have to take 3 and 5. 3 and 5 which is not present in B, so you have to take 3 and 5 only. If you want to calculate a B minus A, then what are the elements you have to take? B minus A means 2 is present, 4 is present, 1 is present, so singleton 0. Okay, if you have all the elements in A, so singleton, so it is called, sorry, no elements are present, it will be a null set. No element is all the elements are present in A, so you should not take any element, so it is null set. Okay, B becomes null set, B minus A becomes null set, A minus B becomes 3 and 4. If you have any single element 6 here, so what will be the value here? 6 will be the value, and it will be a only single element is there, so it will be a singleton set. Only single element is there, so it will be a singleton set. B minus A, if 6 is present in your B, so it will be a singleton set. Okay, now let us start an exercise. While solving the questions of exercise, you will be more clear with the concept. Okay, if given what are the values of A values are 1 2 3 4, and what are the values of B? 1 2 3 5 6. Then what we have to find A intersection B and B intersection A, and we have to prove are they equal. Okay, find A intersection B. A intersection means you have to take the elements which are common. So okay, here 1 is present in both of the sets, so 1. 2 is present in both of the sets, 2. 3 is present in both of the set, 3. So A intersection B value is 3, 1, 2, 3 is present. 4 is not present in this set, so no element is common. 5 and 6 is not present in set A, so these elements are not common. 1, 2, 3 are common, so A intersection B. Now find B intersection A. Now B intersection A, what is the value of B intersection A? See the common elements. 1 is present in B and A also, 2 is present, 3 is present. So 1 is present, 2 is present, 3 is present. 5 and 6 is not present in set A. So 1, 2, 3, 1, 2, 3. So here we can prove that A intersection B, values of A intersection B is equals to B intersection A. Values are same, 1, 2, 3, 1, 2, 3. So here we have proved A intersection B is equals to B intersection A. Comes to the second question. Here what it has been given, set A equals to, given set A equals to 0, 2, 4. What we have to find first one, A intersection 5. A intersection 5. What is the value of A? 0, 2, 4. And what is the value of 5? Nothing is there. So what we have to take, A intersection 5. What is the element in common here? No element is common, so it will become singleton value. No element is common, no, it will become singleton, it will be null set. So what we have seen, A intersection 5, A intersection 5 is equals to 5 only. A intersection 5 is equals to 5 only. If you do the intersection with the null set, null set only will come. Okay, and the second one we have to prove A intersection A. Now take the value A intersection A. What is the value of A? 0, 2, 4. Intersection, what is the value of A? 0, 2, 4. So when we do the intersection of A intersection A, this value becomes 0, 2, 4. Yeah, when you do the same values intersection, what are the common elements present here? Here it will become 0, 2, 4. Okay, common element, what will it will come? 0, 2, 4. Okay, it can be represented in the diagram also. Mu A intersection A. A intersection A means A only comes, no, so only A set A will come. And if you A intersection represents this in the diagram, A intersection 5. What is the value here? 0, 2, 4 elements are there, but in singleton no values are there, no. Take the intersection here, 0, 0, 2, 4 values are there, but in the intersection no values are there. So what are the values are here? No values will come. In this no values will come, it will be a null set, and in this set A will arrives, set A will presents. Okay, A intersection A is A, and A intersection 5 is, A intersection 5 will be null set only. If A equals 2, 4, 6, 8, 10 and B equals 3, 6, 9, 12, 15, find A minus B and B minus A. Okay, what is the value of A given? 2, 4, 6, 8, 10. What are the values of B? 3, 6, 9, 12, 15. And what we have to take? A minus B. This is the first step, so take A minus B. A minus B. In A minus B, what we have to take? The elements of A, and you should not take what are the elements in common also. So what we have to take? A minus B means 2, 4, 6, 8, 10 minus 3, 6, 9, 12, 15. Means not even a single element should be in set B. Okay, only you have to take set only A. Means 2 is not present in B, so 2 is there. 4 is not present in B, 4 is there. 6 is present in B, so we should not take 6. 8 is not present in B, we have to take 8. 10 is not present in B, 10 is there. So what is the value of A minus B? 2, 4, 8, 10. Okay, we are taking only the A elements, not the B elements. Okay, now take second one, B minus A. Okay, B minus A means 3, 6, 9, 12, 15. 2, 4, 6, 8, 10. What is the value comes? 3 is not present, so 3. 6 is present, so we should not take 6. 9, 12, 15. So what is the value appears for B minus A? 9, 3, 9, 12, 15. And for A minus B, 2, 4, 8 and 10. Okay, this is first one, this is second one. Now comes to next question. Now if A and B are two sets such that A is subset of B, what is A union B? Now let us continue. I'll explain you in the diagram. Consider this is universal set. We are not talking about universal set, we are taking A is subset of B. So this is B. This is the value of B. Take 1, 2, 3, 4 elements and A. This is A. 5, 6 element. Okay. Then A here we are taking as A is subset of B. Means what is the value of A union B? A union B means you have to take all the elements 1, 2, 3, 4, 5 and 6. Okay, by representing the diagrams, A is subset of B means A has the elements which is subset of B, and A union B. A union B means I'm writing beta here. A union B means we are taking all the elements present in A and B. Then what will be the values come B? All the elements present, it also equals to B. Okay, I'll give you another example. Take the elements A as 2, 4, 6, 8. Take the elements of B as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so all the elements of A should present in B. This is all the elements of A should present in B. This is the value A is subset of B, where all the elements of A is present in B, and we have to find A union B. A union B means 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Means all the elements of A and all the elements of B together forms the union of the set. So what will this value comes? This value comes as B. Okay, this value is equals to B. So what we have noticed, if you take the union of A union B which belongs to B, if condition what, A is a subset of B. If all the elements of A is present in B, then when you take the union, the value will comes B only. Now in the fifth equation it has been given A, where set x is a natural number. Set A is a natural number. Set B is given as x such that x is an even natural number. Okay. Set C, x such that x is odd natural number. Set D x such that x is a prime number. It has been given like that. Let us take set A. The values of x will be 1, 2, 3, 4, 5, 6 and so on. Yeah. What is B? Set B values will be, B values even natural numbers 2, 4, 6, 8 and so on. And what are the set C? Odd natural numbers. So 1, 3, 5, 7, 9 and so on. And what are the values of D? 3, 5, 7, 9, 7, 11, 7, 11, 13 and so on. Okay, now we have to find that what is the value of A intersection B. We have to find what are the values of A intersection B here. So now write what is A intersection B, what is the value of A? 1, 2, 3, 4, 5 and so on. And intersection B, what is the value of B? 2, 4, 6 and so on. So what are the values common here? In if these 2, 4, 6, all the values of B is present in A, no? So all the even numbers will be present in A, 8 and so on. All the values of B are present in A. Okay, what is the value here? A, what is the value of A intersection B? 2, 4, 6, 8, which is equals to B, no? Okay, the second one we have to find A intersection C. What is the value of A? 1, 2, 3, 4, 5 and so on. Intersection, what is the value of C here? 1, 3, 5, 7 and so on. Odd natural numbers are present, so we are taking 1, 3, 5, 7. Okay, then what is the value of A intersection C? 1, 3, 5, 7 and so on. Common elements are there, odd numbers are, all the odd numbers are present in the natural numbers, so this value becomes C, no? But what is the answer? You can't, if you not write C also, it will, nothing will happen. But 1, 3, 5, 7, all the values are present in A. Comes to the next question. Now we have to find A intersection D. Then what are the values of A? 1, 2, 3, 4, 5 and so on. And what are the values of D? 3, 5, 7, 11 and so on. Prime numbers, all the prime numbers are the value of D. So what will be the answer? Intersection 3, 5, 7, 11 means all these values are present in all the natural numbers. The next question is, we have to find what is the B intersection C. What is the value of B? 2, 4, 6, 8, all are divisible by 2. And intersection of C means odd numbers, 1, 3, 5, 7, 9 and so on. Okay, in these, see the comments, these are all the even numbers and these are all odd numbers, means not even a single number is present in both of the set. Common is present, is common in both of the sets. So what will be the answer? Will comes no elements. This is the null set. Okay, void set means not even a single element is present, is common in both the sets, all the even numbers, all the odd numbers, not even a single element is present. Okay, now find B intersection D. B intersection 3 D, what is the value? 2, 4, 6, 8. Yeah, intersection D, 3, 5, 7, 11. Okay, this is all the prime numbers and these are all, sorry, 2 is also, sorry, I didn't take 2 is also a prime number. So what is the value here? Common, 2 is only the common. The remaining are the remaining numbers are all divisible by 2. So only 2 is a common here. Only 2 is common. 2 is common here. Sorry, I didn't take 2. Okay, 2 is common here. 2 is a single prime number. Now find C intersection D. In C, what is the numbers are they? 1, 3, 5, 7, 9. Okay, and intersection D means 2, 3, 5, 7, 11. Okay, all are prime numbers. So what are the common numbers here? 3, 5, 7, 11, all are prime numbers. Okay, all are common here. 2 is not there in set C. So we are not taking 2, we are taking the remaining number. But 9 is also not present in set D, so we are not taking 9 also. Okay, we are taking only the prime numbers here, odd prime numbers. Okay, now continues with the next question. Here also it has been given the values of A, the values of B, the values of C, the values of D, and now we have to find A minus B. Means what are the, we have to take A minus B. What are the elements of A? 3, 6, 9, 12, 15, 18, 21. Minus what is the value of B? 4, 8, 12, 16, 20. Now we have to take only the values of A, but not values of B. Not even a single term which is common in B also. Okay, 3 is not present, so 3, 6, 9, 12 is present, so cancel 12, 15, 18 is not present, so 18, 21. These are the values of A minus B. 12 is present, we are cancelling 12. Okay, the second question is A minus C. What are the elements of A? 3, 6, 9, 12, 15, 18, 21. Okay, what is the values of C? 2, 4, 6, 8, 10, 12, 14, 16. So what is the value of A minus B? 3, 6 is present, to cancel it, 9, 12 is present, cancel it, 15, 18, 21. This is the value of A minus C. Comes to next question. Next we have to find A minus D. What is the value of A? 3, 6, 9, 12, 15, 18, 21. Minus D. What is the value of D? 5, 10, 15, 20. So what are the values we have to take? 3 is not present, 3, 6, 9, 12, 15 is present, cancel it, 15, 18, 21. Okay, now taking fourth question. B minus A. Finding the value of B minus A. What is the value of B? 4, 8, 12, 16, 20. Minus A. 3, 6, 9, 12, 15, 18, 21. Okay, then what is the when subtracting, what is the value comes? 4, 8, 12 is present, so cancel it, 16, 20. Okay, now finding the value of C minus A. What are the values of C? 2, 4, 6, 8, 10, 12, 14, 16. Minus what is the value of A? 3, 6, 9, 12, 15, 18, 21. What are the common words? 2. 4 is not there, 4, 6 is there, so cancel it, 8, 10, 12 is there, so